Hello, hi everyone. Welcome to LondonR Online. Just to go over a couple of things, if I could ask if everyone could make sure they're muted during the workshop and have your camera off. If you'd like to ask questions, can you please ask them within the chat function of Zoom? So if you, with your mouse, you'll be able to see, there's a chat bit, and then just send your question to everybody, and then one of the presenters will ask a question. This workshop is also recorded, so please bear that in mind, and the slides and the recording will be made available to you from tomorrow. So let's get going. I am Laura. I am the events and marketing coordinator at Mango Solutions. So just a little bit about Mango. We were formed in 2002. We're based in Chippenham, Bristol and London. Of course, most of us are based remotely from our homes at the moment. I'm based in Bristol currently. And we empower organizations to make informed decisions using data science and advanced analytics. And we also arrange a range of data science events. So we do LondonR, Bristol Data Scientists, London Data Engineers, and also the Earl Conference, which we're now hoping to host online this year. So more details about that will come soon. Just about what we've been doing since COVID-19, we've taken quite a few of our offerings online, so we're now capable and set up to offer our training and our courses online and virtually. If you would like to speak at a future LondonR, please drop us an email at events@mango-solutions.com if you'd like to present. We're hoping to host one every month now that we're doing it online. And then tonight we have a brief introduction to the Tidyverse hosted by Joe and Andrew from the Mango team. So thank you to them. If you'd like to tweet, the hashtag is #LondonR. So yeah, great. I will now stop sharing my screen and hand over to Joe and Andrew, who will be hosting tonight's webinar.
Yeah, cheers, Laura. It's great to meet you all kind of virtually. This is kind of a new experience for us, so kind of bear with us while we kind of get started with this, kind of getting used to this. The first thing to kind of mention is that we'll be going through kind of an example with some example data for this kind of tour of the Tidyverse. If you look at the chat, you'll be able to see that I've kind of posted a link there, which will take you to a GitHub repo. And from there, you'll be able to download all of the data that we're going to be using throughout the session, as well as some of the scripts that we've been looking at, as well as the kind of the solutions that we'll have, some of the exercises that we'll have during the workshop. So I'd strongly encourage you to go to GitHub link and kind of download all of that information from there. If you do have any issues with that, please shout in the chat and we will try and kind of resolve those issues. But yeah, it's great to have you with us. So yeah, Andrew, we all set up?
Sure. Yeah, I'm hoping everybody can see my screen all right. I'll start sort of as Joe has, just introducing myself. I'm Andrew. I work at Mango as well. I'm a junior data science consultant and been at Mango about 9 months.
Yeah, fantastic.
You, Joe? Yeah.
Yeah, sorry, I didn't introduce myself either. Yeah,
no worries, you don't have
Andrew. Yeah, so we're going to be having what we're going to be doing today. It's kind of a light-hearted, like kind of look at the tour of the Tidyverse. So if you don't know what the Tidyverse is, it's kind of this framework, this kind of collection of packages that we use when working with R. If some of you kind of are R experts, I'm sure you'll be very familiar with the Tidyverse. So if this might be kind of below your standard, then don't worry, you're more than welcome to stay and have a kind of a refresher if you like. We're going to be kind of taking a kind of a dip dive into this Tidyverse, these Tidyverse set of packages. Have you got any more to say on that, Andrew?
No, I mean, yeah, I mean, Tidyverse is definitely like the main thing that you use for the majority of projects when you start out using R. Tidyverse in itself is a collection of packages. So for those who don't know, packages are just sort of like R add-ons where you can just use other people's objects and functions that they've created. And the Tidyverse is just a collection of those.
Exactly.
But yeah, I mean, very, very useful. I think me and Joe have both used it a lot throughout our time, pretty much from the day we started till now. So yeah.
Yeah, definitely. Yeah, cool. Grand stuff.
So the data that we're going to be using is some data on the funding of Olympic sports from the Olympics in 2000 at Sydney all the way up to Rio, I believe. That'll be the stuff that we'll be using for like the examples. But then we also have different data for the exercises, and that'll be this uni result. I think it's results actually, maybe uni result. I'm not 100% sure. .csv, which hopefully you guys will have received by email. If not, there is a GitHub page which you may be able to download it from. I don't know if Joe's posted that in the chat.
Yeah, there.
You have? Yep. So I haven't actually been checking the chat myself.
I haven't seen any issues so far.
Yeah,
so people looks all good.
Yeah, as I say, if anybody has any issues throughout, obviously there's 2 of us here, so yeah, feel free to sort of message in the chat and we'll try and sort everything out as quickly as we can. So what is the Tidyverse? I think we kind of sort of briefly mentioned. It's a group of unified packages. There are core packages and there are sort of like less core ones, basically.
Extensions, yeah.
Yeah, but I mean, realistically, if a package is in the Tidyverse, it's very much seen as core in some sense to R. Packages are obviously still divided up as you'd expect for different tasks. And then the Tidyverse itself is just for a range of tasks that you might want to do. But we'll sort of go through that and the workflow that you might use throughout.
Yeah, absolutely. Yeah, so that kind of brings us to this kind of initial, I guess, the tidy philosophy, which Andrew just put on screen now. This is kind of, I think Hadley Wickham, one of the main guys who kind of works with these Tidyverse packages, he kind of has this philosophy about kind of when you're writing code, you want to kind of make it really readable for the human. So like when someone else is kind of reading your code, you want to be able to have that code be really readable so that other people can understand exactly what's going on, what analyses you performed without too much overhead and understanding. So that's kind of one of the main kind of philosophies of this Tidyverse. And you'll be seeing how these kind of functions that we'll be using, how they kind of the naming convention, the way we use them makes it really, really easy to understand and really easy to get a grip of what's going on.
Yep. Yeah, definitely. I think the readability is a really important point as well. I mean, it's not just other people, but you know, quite often on projects, you'll go back to code that you've not looked at for a week, and the way functions are sort of structured in the Tidyverse makes it very easy to just see exactly what you're doing. You know, the way the names are very descriptive, the use of the pipe, which we'll see later as well. Yeah, very helpful to sort of keep yourself organized.
Yeah.
So this is, as I say, the sort of workflow that you might expect to be using on a project or whenever you're using R. We're going to be sort of taking you through this mostly sort of following these arrows, starting with importing your data, then tidying it, which we'll sort of expand on later, transforming it to the state that you want to have it in, a recursive cycle of then visualizing, modeling, and transforming it again. And then finally, once you've got everything that you want, somehow to communicate that. But that won't strictly be part of the Tidyverse, but we'll come to that later.
Yeah, absolutely. I think this is just kind of your typical data science kind of workflow, isn't it? And kind of the Tidyverse guides you through this really nicely, which we're going to look at. I
think so, yeah. So these, as I was mentioned before, are the core 6 Tidyverse packages. Use them daily. I'm sure if any of you out there have used Tidyverse a lot, you would have probably used these packages independently from the Tidyverse. The thing with the Tidyverse is just it's nice that you don't have to load all of these in independently. That's almost like the main point. It literally just takes these packages and allows you to load them all in together. So when you know that you're going to be doing some type of work, you don't have to go through and check which ones you're using, and you know, just library it in. It's all there.
Yeah, exactly.
Cool. So the first thing we're going to go through is importing data. Depending on what type of data you have, you may use one of these different packages. These here are all different types of packages for importing your data. The most common one is readr, you can import quite a few different types of data, but mostly this is just your standard tabular data. So CSVs, Excel documents, that sort of thing. Haven, which is used for SAS type data. I can't say I've used that too much myself. Have you, Joe?
No.
No, yeah, we don't actually use SAS much at Mango, so yeah, we haven't used that. Read Excel, which is I think a faster way to import Excel documents, importing different sheets and that sort of thing. JSON-Lite for JSON files. HTTR, I'm not 100% sure what that is. Joe, use that one?
I think that's, to be honest, I can't remember off the top of my head.
No,
I feel
no
that's
worries.
web scraping something.
Yeah, and then rvest is definitely web scraping. So that's almost like reading HTML tables from like a website, that sort of thing. And then XML2 is XML documents. So going into the most common one, which is importing tabular data. For this, you'd use readr. The most helpful, the most common function you use in readr is read_CSV. And then you literally just put the path to your CSV, and that will read that in as an R object. There are a few other variants, which are read TSV and read_delim, which basically just mean if you have your data stored, instead of having comma separated values, which is what a CSV is, you may have them separated by some different delimiter, so maybe a dash or / or something like that. You can choose that yourself. But I think this is probably a good time to show you the first actual demo. So I'm going to flick over to RStudio. Can everyone see that all right? Or Joe at least?
We can't.
You can't
Still
see
on the
that?
PowerPoint.
Oh dear. In that case, I'm probably just sharing the wrong type of screen. So bear with me 2 seconds while I try to share my whole front screen. See if that works. If I flip over now, is that right?
Hey, there we go. Perfect.
Fantastic. That's great. So yeah, so the first thing we're going to be doing is reading the Summer Olympics funding CSV. So hopefully if you have all had the data, then you'll be able to find this. Now, when you specify where you want to read from, so you type in read CSV, and then you want to specify the path. So in R, you always have a working directory, and that's just almost like where you are on your file system. You can find out where that is by going to the console and doing get wd, just to find out exactly where you are. So you see for me, this is where I am currently. And then anything you specify from that, you can use a ./, and that will take you to your working directory, and then you can continue from there. You see if you do the tab as well, then that comes up with all the different options in there to sort of view them a bit more nicely. So we're going to be reading in the Summer Olympics funding, which I believe is in data. And so you just navigate to the path like that. You see it's a lot quicker when you use the tab complete. To actually, when you read this into R, obviously you need to actually, you need to have it somewhere. You can't just sort of read it generally. And so we need to assign this to an object. So let's say assign this to the summer object like that. Now, this is a classic problem. You see what I've done really stupid here. So it couldn't find the function read CSV. It's because I've basically forgotten to library in the Tidyverse, which is the first thing you want to do. So whenever you use a package in R, you always want to library that in. So I'll library in the Tidyverse, and what this does is it basically loads all those functions within your R session. So it has them sort of there for you, ready to use. So we'll always do that first. This may take a second just because the Tidyverse is quite big. See how it's loaded in there? And then we can read that in. Don't worry too much about this warning. This is just telling us how it specified the characters, how it specified the different columns from within the data set. So it's assuming that these are all characters, which you can see from this. So if we actually have a look, this is what we currently have. So you see it specifies it as a tibble, which is something that we'll go into a little bit later, but essentially we just have a data frame here with the columns that you can see there. There are a few sort of instant issues that we have with this data. The first one is our NA values. So you can see that there are a few different ways that NA has been entered in this data. Sometimes it's been written as n/a, other times n/a with double star. What we can do is we can actually define those all to be actual NAs within R by filling in the NA function from read CSV. So you read it in, and then you choose which of the characters that you want to specify, you want to turn them into NAs. So here we'd specify n/a as a vector, and then also n/a double star. Let's just make sure you can see that all right. And hopefully you can see that those have now been converted to NAs. So that's one of the features that you get from read CSV. Now these columns, you can see that they've all been, they all have like a column type here. So this CHR here just means that they're character type. When we read them in, we may want instead them to be different types. So you can specify how what you'd like them as by using the read CSV argument col types. So clearly, sports here is still text. We want that as a character. But the other ones, such as Sydney, Athens, Beijing, and London, and Rio, they're all numeric. So we'd actually prefer to see them without a pound sign and just as a number instead. So we specify the col types. Here we have to use a function cols just to define how we're going to specify them. You can then use .default to say what you want your default column to be. So here we're going to say we want our default column to be, let me just create a little bit more space. To be a character type, we do .cols.default equals col_character. And then set, sorry, I apologize. We don't want that as our default at all, do we? They're all numbers. We want col_number. And then we want to specify that the sports one is a character. So there we go, sports. I apologize. Oh, God. Sorry, a few teething issues here. Sports equals col_character. And now if we have a look at that, we can see that they've all been updated. And these have been converted to numeric. So instead of the pound signs being here, we just have a numeric here. So this is sort of how you'd import your standard type of data. You see there's a few different arguments you could use, but basically we're just specifying a path to our data and then assigning it to an R object. Let me flip back to the PowerPoint. So yeah, I mean, there's a few variants on this. I'm not going to go into them because I think it's a bit of a waste of time, but they'll all be following the same sort of ideas. So specifying a path and then using other parameters to define extra information, like the column type, for example. Read Excel is another package from the Tidyverse. So the last one was read_CSV, which came from the readr package. This package now is Read Excel, and this is just a bit faster for using Excel documents. So I'm sure many of you know that you can convert CSVs, you can convert Excels to CSVs anyway. So you could always do that from Excel. But if you want to read it straight from a .xlsx document, then you can use the Read Excel package, and the function is Read Excel, and then you can also specify the sheet as well. We briefly mentioned the other cases as well, so just different types, different packages also within Tidyverse Haven for SAS data, XML, and JSONLite for JSON files. And that brings us straight away to our first exercise. So I'm hoping that you will have access to the data. As you see, we've got a CSV. So we want you to read in the uni results.csv using appropriate package and function. If you do have any issues with the exercise, you're stuck or you can't find the data or anything like that, please just post in the chat and hopefully me or Joe will help you out. But I'll give you, I'd say, 5 minutes or so. Get through that. If people are finishing quick, then we'll start again earlier.
Hi, Andrew. There are just a couple of questions on the chat, if you can take a look at those.
Yeah, no worries. I was actually just reading through that just now. So most people have got the data. When can we ask questions? Sorry, probably should have said this at the start. Please feel free to ask questions throughout. I think it's probably, with something like a workshop, it's definitely more easy to do that. So yeah, don't be afraid to just interrupt us if you want. I'm fine with that. If you feel more comfortable, post it in the chat and hopefully the other one of us will answer as well. So completely up to you. Where's the path to the uni data? Okay, so I've just posted in the GitHub page for the data if that helps anybody get it. So Vara, I've just seen the you can't download it. It may be that you have to sign in. If you don't want to sign in or you haven't got a GitHub account, we can get it to you another way. You're signed in, and it's not. That's strange that you can't. Joe, how's the Dropbox looking? Is that, what about that? Is that, do we think that's operational? Because we could maybe send people to that if that's better.
Yeah, maybe that's a good idea. I can share a Dropbox link which will have the data in as well. I think you will have to download Dropbox, so that might be might not be a solution either. But I guess it's worth sharing that either way. So I'll just pop that on the chat now.
Yeah, it'd be great if you could. Just going to put another link in the chat as well to, I think, what is a different GitHub page. So try that if not. Oh no, wait, that's the same one. Is anybody still having trouble? Sorry, I know we didn't have two of the best solutions there, but if anybody still can't get it in, put something in the chat and we'll see what else we can do. Nice, thanks for that, Curates. That's great.
Yeah, that's a good question. I've just seen your question about using tibbles instead of data frames. We'll actually come into that in the next kind of chapter, looking at tidy data, kind of the benefits of using a tibble. But effectively, there isn't much difference, but there's a couple of small differences. We'll go over that in the next chapter. Thanks for the question, Marta. Sorry if we missed it before. I can't personally say I've used Tidyverse on Databricks or kind of any of its conflicts with Spark-R. I can't actually say I've got too much experience of that. I know some of our other consultants have kind of worked on those sort of projects where those sort of might be an issues. So I wonder if that might be a kind of a conversation that another LondonR might be more useful. If we're in person, it obviously would be much more easy to direct you to someone that would know the answer to that. But I'm afraid I don't personally have any experience. I don't know if you do, Andrew, but I imagine not knowing the projects you've worked on recently.
Yeah, no, I'm afraid not either. Yeah, that doesn't mean too much to me if I'm being completely honest. So sorry about that, Marta.
Yeah, apologies.
So if people are still struggling to get the data, I've just seen a message, do I need to download GitHub? No, so GitHub is a web page that hopefully you should be able to download the data from. It's where we're almost storing it. Hopefully on that page that we sent in, you should be able to find a way to actually download it from the page. If not, try the Dropbox link. That, unfortunately, you would actually need to download Dropbox to be able to access that. Hopefully, the GitHub one, you wouldn't need, there's nothing you'd need to download. You may need to sign in, so try that. But if not, then put another message on saying that you've tried both those things and they haven't worked.
Andrew, I wonder if it's worth just going on to GitHub really quickly and showing where the download link should be, in case people are having issues.
Yeah, I think that's a really good idea. Can you see the GitHub page there? Is that working?
Yeah, I can see that.
I just realized, have I been sharing my chat the whole time? I think I have, haven't I?
No, you're good.
No? Maybe it's because it's a pop-out. I was worried that people were messaging privately and they could see. Okay, so this is the GitHub page. So for me, there is a little button here, code, and you can just download the zip. I'm hoping that's there for everyone else as well. It wasn't there for me before I signed in, so you may need to sign in to get that. So try that. If you've exhausted both options, though, please put a message on the chat. Hi, Khaled. Yeah, just so just so your question, is the Tidyverse compatible to work with all sorts of input data formats other than CSV? Yes, definitely. Almost the idea of readr, which is one of the packages within it, and all the other sort of importing packages, is that no matter where they take the data source from, they try to make it in a consistent format anyway. So whether you're reading in a SAS file using the Haven package, for example, reading in an Excel document using read Excel, reading in a CSV using readr, they'd all come in and they'd all look in sort of a similar format, if that makes sense. So that's sort of the idea. But yeah, absolutely, you can use lots of different data formats. And even if, for example, even if there wasn't an import package for the data type you were using, you still use other Tidyverse functionalities on that data once you've got it in, if that makes sense. Yeah, Joe, I think you're right. It's time to probably go through the answers now. I'm sort of hoping everybody's got it in. I'm slightly worried. I've seen a few people, it almost looks like they may be skipping ahead, or maybe they're using the script and just trying to run the whole thing, which is maybe why they're getting a little bit stuck ahead. But yeah, I think it's best if I just go through the answers now. Hopefully that'll sort of clear up where we are. So I'm hoping that everybody has Tidyverse already installed. If you don't have Tidyverse installed, maybe I should have gone through this at the start. You would do an install.packages and then type in quotes Tidyverse like that. But we're assuming that everybody already has this installed. If not, run this little snippet of code, which I will just post in the chat now. Once you've done that, that will be installed. And then to actually then load all the Tidyverse functions into your R session, you would do the library Tidyverse. So that's the second line here. Once you've done those, you won't have to do them again, basically for the rest of today. And so now I'll move on to the actual exercise answer. So it was to read in the uniresults.csv data into R. So I'm just going to, when you read it in, you always want to assign it to an object. So, as I say, we're not just sort of reading it into general R. We want to actually say this data is this object. So we're saying uniresults, which is just a name we've made up ourselves, is assigned to, and then we read the data in. So read _ CSV, and then in quotes, the path. So I do the / just to say this is relative to my working directory, which is the hopefully the Tour of the Tidyverse folder. Tab to sort of see what comes up, data, and then uniresults.csv. When we run that, that'll have read it in. You see you get this passed with column specifications message, which is just letting us know how it's entered each of the columns, how it's interpreted them. And we can check that it's entered in just by running the object that we just assigned the data to. So you see uniresults is now a thing in RStudio. It recognized that when I hit tab. And so we can run that and it will come up with the data itself. I'm hoping most of you got that once we managed to get the data in. Apologies if not. Yeah, I think that's definitely the best way to do it. Joe, are you ready to sort of move on to the next chapter?
Yeah, fantastic. Yeah, cheers, Andrew. Yeah, cool. Let's have a go at the next chapter. I'll steal the screen, shall I? And then, thank you. Cool. Share my screen. Okay, fantastic. Hopefully you can all see that. Is that coming through? Yeah, cool, great stuff. Okay, cool. So we've looked at our first stage was importing data. Now we're kind of ready to look at the second stage, which is going to be tidying our data. So how are we going to get kind of our data into the right format? We kind of already saw a little bit of that using the NAs, but we're going to take this kind of a step further. So let's go. So we're going to introduce kind of two packages here. Firstly, is this tibble package that I think Andrew's kind of touched on already, which is kind of the format our data is going to take. So normally when we work with data in R, we would use data frames. But we're going to be using this tibble package, which is the Tidyverse kind of uses throughout. And this is just kind of an extension to these data frames with a couple of extra features, which we'll kind of look into. And then we're going to introduce a second package called TidyR. And this is, as you might guess, is what we're going to actually use to the functions in this TidyR package. We're going to use this to tidy some of our data. So let's look at firstly these tibbles. So what is a tibble? I mean, firstly, it's quite a funny name. It rolls off the tongue like that quite nicely, certainly nicer than a data frame. But essentially, it is just a data frame. So it's just an updated data frame we've got here. And this can be created using this tibble package. Which we'll look into in a second, how we're going to create one of these. But there are a few kind of extra features that come with this, with these tibble sort of type data frames. And that is that we kind of only print the first 10 rows. So if we were to kind of print a data frame, kind of one of your basic data frames, so for example, in R, there's a data frame called empty cars. If you were to kind of run the code for that and print it to the console, you'll get the whole thing printed off, which is kind of fine if you've got a small data set. But you can imagine if you've got a data frame with, let's say, 1,000 rows, you're going to get all of those 1,000 rows printed to the console in one go, which isn't very helpful and isn't very pretty. So tibbles kind of quite nice. They only ever print the first 10 rows, and so it kind of stops you kind of printing this mass of kind of data to your console. Secondly, it kind of doesn't create row names, or it removes them if they're already there. That kind of self-explanatory. And this final one is quite a nice one, which you kind of won't realize it's a nice thing until you kind of come into an example, kind of situation where you need to this has happened. So kind of by default, data frames will always convert character columns to be factors, but this isn't always the case. We don't always want this. And so kind of tibble has kind of removed that kind of feature of data frames, if you like. And so it doesn't do that automatically. But yeah, the thing to kind of realize here is that you often won't even notice that you're using a tibble rather than a data frame. Tidyverse works with both data frames and tibbles, but we're just it automatically converts to tibbles for you, just kind of slightly nicer. But really, whenever you hear a tibble, think of a data frame, and they're kind of pretty much interchangeable. So there's a few kind of these tibble functions we're going to look at in a second. So glimpse is the first one. These are kind of some helper functions. So glimpse, just if you want to look at the first few rows of your data, you can use this glimpse function. There's a tibble and a tribble function. So we can use these to actually create these tibbles. We'll have a look at that and a kind of example of that in a second. And then there's also some extra helper functions such as add row and add column, which kind of, as you might expect, allow us to add rows and columns to our tibbles. Yeah. Cool. So let's jump to our studio and just see how we can create one of these tibbles using this tribble function. So I'm going to be using this tribble function that we just saw. And this stands for, this little R here, it stands for kind of doing this by row wise. So we are going to be creating a data frame row wise. And let's call this data frame the years data frame. The years tibble, sorry. I'm getting confused. Cool. And when we're doing this is kind of, you won't do this too often, but if you kind of want to really quickly create a kind of a little data frame, a little tibble for work when you're performing some analysis, this is kind of a really nice way of doing it. So firstly, we kind of going to specify some column names for our data. And we're going to do that using this little twiddle symbol, which for me is just if you press shift and hash, that will get a little tilde. And then I can just enter some column names for my data frame, for my tibble. So I'm going to enter the following column names, so location, year, month, day. And this is going to be some data that we'll use later on in the course for some more examples. Cool. So that's going to be our data for column names. Once we've kind of specified those, we can just actually specify the data we want to be held within those columns. And I'm going to do that by simply entering either the string or the number that I want to appear in each of those kind of cells. So firstly, I'm just going to put this in. So I'm going to put Sydney as the first location. I'm going to put the year 2000. September is the month, and 15th is the day. And I'm going to do this. I'm actually just going to copy this over really quickly, just to kind of save time. But as you can see, what I've done here is I've kind of just repeated this process for the next kind of few years of Olympics with the corresponding months and days. So we kind of have this kind of, you can kind of see it's kind of a kind of data frame, a kind of tibble forming. We've kind of manually input it. So when we run this, we get this years. When we execute that, we can see we get this tibble, and it even says a tibble. And we have these properties where it's only going to print 10 rows. In this case, there are even 10 rows, so it's not going to print them all. And so, yeah, that's just what we're going to use for our tibble. And we'll see this more later on. We're going to use this years tibble later on in the course. So that is the tibble package. Next, we're going to look at the concept of tidy data. And this is kind of a fundamental part of our analysis. Tidyverse, as we've already mentioned several times, is kind of designed to work with tidy data. And this is kind of a structure that's kind of consistent and common to all of these packages. So we're going to actually look at what it means to be kind of tidy data. And there's kind of three key points to this. There's three principles to this concept of tidy data. Firstly, we want each of our variables to only have one column. So we kind of saw in our example there, our location, of course, we're kind of one column. We don't want to have like kind of two columns where we might have location 1, location 2, and we have kind of different values for each of those kind of dispersed. We want to have just one variable for each column. The second principle is that we want to have each observation have its own row. And so this is when we were kind of creating our data frame just then. We just want each of our observations, each of our values to only have their own row. And then finally, we want each value to have its own cell. So you just want kind of an extension of these two, kind of if you apply each of these two principles, you should get this final principle that each value has its own cell. And so sometimes our data we might be importing, this won't be the case. And so we need to use some functions to kind of make sure that we kind of apply these principles. And so there's kind of two functions we introduce, kind of pivot longer and pivot wider. And then there's a kind of final function we won't look at, but it's kind of useful to know. It's called separate. But what these pivot longer and pivot wider functions do is they allow us to kind of, firstly, pivot longer. It allows us to kind of take our data frame, take our tibble, and it takes the kind of column names and it kind of makes it longer. So it takes some columns that maybe aren't a single kind of variable for each of the columns, and it will kind of fix those issues to get it into a tidy format. And then a separate column. If we have a column that maybe has two observations in it, two values in it, we can split those two columns into two separate things using the separate function. So let's actually look at using this pivot longer, and I think this will be more obvious once we actually use it, what's going on here. So let's tidy the data. So we're going to be kind of continuing from this summer data frame. So let's quickly have a look at what this summer data frame looks like. So as you can see here, we have a number of sports. Then going across, we have these kind of locations. And then in each of these locations, we have kind of a value. And this is fine. But actually, it's not kind of really following these principles. We kind of want instead of having the kind of locations going across the top, we want to have a column of locations. And then for each of those locations, we want a kind of single value for the value of funding for each of those locations and the sports. So we're going to kind of take this data frame, which currently you would say is wide data, and we're going to use this pivot longer function to kind of make this wide data frame, make this wide tibble to be a kind of a longer, we're going to pivot wider, so we're going to make this data frame longer. So let's, I think There's always quite a complicated one to kind of first get your head around, but let's kind of use this function to see what the output looks like, and I'm sure hopefully that will kind of clear some things up. So let's use pivot longer function. Firstly, we need to just apply the data frame. This is kind of consistent with all the Tidyverse packages. We always supply the data frame as our first argument. The next thing we want to supply is the columns. So we're going to be kind of collecting all of these columns into kind of two separate columns. And we're going to tell this pivot longer function which of these columns, which of the columns in this current data frame, this current tibble, sorry, you see I'm getting mixed up still. Which of these ones we're actually going to kind of collect and make longer. And we're going to collect everything except the sports column. So we're going to collect the Sydney, Athens, Beijing, London, and Rio de Janeiro columns. Now I could go through and kind of specify all of these individually, but actually a much quicker way is to kind of use this calls argument. I'm just going to specify a minus sign and then put in my sports column. So this is going to select everything except the sports column. We're going to kind of collect and make longer. Next, we need to define the kind of the two new columns that we're going to produce in our kind of output data frame. And we're going to use this names2 function, sorry, names2 argument. And this is what our column names are going to go into. So this is going to go into, we want to call this a location column. So these Sydney, Athens, Beijing, London, they're going to go into this location column. And the second thing to do is to provide the name for our values. And we're going to use a values2 argument. And this is what we want, these kind of numbers. What do we want this column to be called that's containing our numbers? And we're going to call this funding. And let's execute that to see what we've kind of done. So as you can see, we've taken our data, we've kind of collected these column names into this location column. And then we've collected all of the funding values, the corresponding funding values, and they've kind of gone into this funding column. So this is kind of, we've kind of made our wide data to be long into a long format. And this kind of much better follows the Tidyverse, the tidy data principles. So let me just save this to our summer variable. Okay, cool. So we've kind of tidied our data now. The final kind of thing we're going to look at is replacing missing values. So let me jump back into our studio really quickly. You might have noticed this first value here. We have an NA value for this funding. So we don't know what the funding was for archery in Sydney. Now this is fine, but we might want to replace that with something that makes a bit more sense. So we're going to use this replace NA function to actually replace all of these NA values with something that makes a bit more sense. So what am I going to do here? So firstly, I don't know if we've seen this already. We've seen the pipe, Andrew, I can't remember, but we're going to introduce a pipe. So what this pipe does is it takes everything on the left of the pipe and it's going to pass it into the first argument of everything that's on the right. So we're going to kind of, on the left of our function, we're going to have kind of this summer data frame that we've just returned here. So this whole thing is going to go into the first argument of the function we supply now. And we're going to use this replace NA function, which, as you might have guessed, replaces all the NA values. And all we need to do with this is the first argument, as you can see, if it's really small, but the first argument is the data. But because we've used this pipe, the first argument automatically is going to be this data that we've specified here. So all we need to do is specify the replace argument. And we're going to kind of give it the values that we want to replace all these NA values with. So what we're going to do here, we're going to replace, we need to specify a list. This is slightly confusing, but we're going to use a list object. And we're going to name this list, and we're going to put funding equals to 0. And this means that everything in the funding column, that's NA, we're going to replace that with the value 0. So let's execute this now, and we've assigned it to our summer variable. So now let's quickly view our summer, and we can see that indeed we have replaced that NA value with a 0. Cool. Okay, so that's kind of all we have for these tidy functions. We've got another exercise, kind of extending what we've looked at so far with this uni results data. So let's try and have a go at that using this pivot longer function. Cool. I'm going to make no apologies here, but we're going to put on some little elevator music just for just a bit of fun.
uses a lot of, thank God that's over, which is using a lot of pipes.
Is that the music finished? Okay, I think I'm going to go through the solutions for this. So let's put a pause to the music, which might be a relief for some of you. Cool, let's go through the answers. So what were we actually asked to do? So we were asked to, using this union results, kind of extending what we've looked at with the read chapter, transform the data so that there is only one column of test scores using this pivot longer function. So we're going to want to kind of make this only one column of test scores. So let's look at our data. So I'm just going to clear that using Control now. So currently we have, this is our data, and you can see, sorry, I've already had union results. It looks something like this. Okay, cool. So you can see that we have kind of these columns up here, and we actually have two test scores. We have test score A and test score B. So it's asked us to kind of combine these two columns into just a single column with the values in a separate column. So let's look how we would do that. So I'm going to use pivot longer here, like we kind of mentioned in the exercise and in the definition. And as always, we're going to pass in the data frame, the tibble, as the first argument. Next, we're going to specify the columns that we want to include. Now, previously, I kind of just did minus, and then kind of, because we wanted to do all of the kind of gather all the column names except one of them. But in this example, we've got actually just two columns that we're kind of gather, and then the rest of them we're going to leave as is. So to do this, we're actually going to need to use a vector. So we're going to create a vector with just the names of the two columns that we want to gather. So let's call this, so we're just going to call test score and test B score. So now it's going to gather those two columns. Okay, great. The next thing to do is to specify what we want these test score A and test score B values, what we want the column name of those to go to. So we're going to use this names to argument, and then let's call this the test. They're going to go into a column called test. And then finally, we've got to do the values too. So these values in these two columns, so 77, 79, etc. What do we want those values to go to? And let's just put that into a column called test score. And when we run that, hey presto, we can see that on the right here, we've got a test with either test A score or test B score. And then we've actually got a test score for each of those corresponding values. So we've kind of taken our Y data and we've pivoted it longer. And let's just assign that to our union results. Okay, grand. I think that is all for this chapter. Again, if you need any help or kind of want to go these again, these are all available on the GitHub repository. So feel free to get a look there. But otherwise, Andrew, I'll pass over to you if you're good to go.
Sorry, I just realised I was muted there. Yes, I am good to go.
Fantastic.
Let me just try and share again. I think I've learned how to do it correctly now. Is that me? Apologies, I have to skip to where we are. God, I hope I don't have to do this every time. Yeah, so now we are on the transform section. So we've imported our data with readr. We then tidied it to make it in the correct format using pivot longer. I think we used pivot longer. It wasn't pivot wider, was it? Pivot longer, I think. So yeah. that is now tidied and in what we call tidy format, where you have all your values and each row is an observation. Now we are going to go into what I think is the most useful package in all of the Tidyverse, which is dplyr. And yeah, this is used to transform your data. So we're actually going to be making changes to it. I apologize, there are actually a few packages here actually that we're going to go through in the transform section. dplyr, I think, is the most useful one. This is something that I use pretty much every day, I'd say. Forcat, which is for categories. So when you have categorical data, it's for making changes to do with factors, that sort of thing. stringr, which is for working with strings. So for those who don't know, a string is literally just like a bit of text. So if you had, say, hi, my name is Andrew in quote marks, that would be a string. And then you may have a vector of strings. And that's what we call a character vector. So string R is for use with characters and strings. HMS is for use with times. So HMS just stands for hours, minutes, seconds. So converting stuff to a nice time format. And then lubridate is for working with dates, which I think is a pun on lubricate, but I mean, it's not the name I would have necessarily gone for, but that's what they called it. So that's for working with dates. Now, the package I'm going to look now at is dplyr. The 5 main dplyr functions or verbs, as they're described here, are filter, select, arrange, mutate, and summarize. Filter is what we use when we basically want to reduce the number of rows in our data set. Select is where we want to select certain columns. Arrange is for sorting the data set. Mutate is for adding new rows. And then summarize is for creating summary data sets. And then we also use group by, which allows our actions to be formed by group, but we will go through these in a lot more detail now. So this is the function filter. As I said before, this is for reducing the number of rows. So the data set we had before summer that we loaded in, we may want to say, okay, we only want the rows where the funding was equal to 0. So what we do is we write no funding, which is going to be our new data set returned by filter. And we're going to assign that to be filter of the original data set. So summer, that's our first argument, the original data set. And then the second argument is a condition that the row needs to hold to be retained in our new data set. So for anything that we're going to keep within our filter, we basically need to have this condition to be true, this condition here. So we're only going to keep rows where the funding column is equal to 0. So I'll just try to implement that actually now within our studio as well, just so you sort of have a bit more of a demo. Just to sort of see what you're getting. So this is what I've still got actually. I haven't done my pivot longer yet. This is what I believe you guys should have now for summer. So you see we've got a data frame, or technically a tibble, but basically a data frame where we've got sports, location, and funding. Now, currently, you see it's 140 by 3, so it's got 140 rows. We say we only want to keep the rows where, for example, funding equals 0. We could have done that. I'm going to do a different condition here. So I'm going to say keep the rows where location is one of, basically is what that means, Athens or Sydney. So this in is just an R special. You just do percentage in percentage, and that basically just gives you a true or false. Is the location that we're going to be looking at, is that in this vector, Athens or Sydney? So it'll go through the locations on each row and decide, is that in Athens or Sydney? If it's not, it won't keep the row. If it is, it will keep the row. That's probably the easiest way to look at it. So if I run filter on summer with this condition, you can see instead of 140 rows, we've now only got 56 rows, and all the locations are going to be Sydney or Athens. Anything else? Yes, we did say we talk about the pipe a bit, didn't we? So the pipe you can do by percentage greater than percentage. That's called the pipe, this thing. You can also do it by doing Control-Shift-M if you want to do loads of them. Not that you ever would. The pipe, basically, it's an operator that shoves whatever you just had into the first argument. So you see here I've written filter summer, and the second argument is my condition. Instead, what I could do is I could start with summer and then do a pipe, and then pipe that in to the filter. That means, so filter will now know that the first argument is whatever was before this. So it'll say, okay, we know that we're going to be filtering summer, and then you can just put the second argument straight in to filter. the reason people do this, you might just think, why are you overcomplicating things? The reason people do this is because it makes it a lot nicer to view. So when you're doing lots of different things at once, you end up with loads of different pipes and chains. So you might filter it, then select, then do some mutating. So actually it makes it a lot more readable. So instead of saying, oh, we're going to filter summer, then select this, you say, okay, we'll take summer, then we do this to it, then we do that to it, then we do that to result, and you sort of chain your results like that. So you'd end up putting like a pipe on the end of this and then doing whatever you needed to do next. So that's why I think they're nice. As we sort of chain our results, you'll sort of to see it a little bit more. You end up with something chain, something pipe, and it looks a lot more readable, I think. Maybe not that obvious in this example. Let's go back to the PowerPoint. So that was filtering. So we have our data set, then our condition. Okay, I thought there was going to be a slide on selecting, but if not, I'll just go through it myself. So select allows us to select one of the columns. Really quick demo. Summer, say we're going to pipe it in because we're going to use pipes now. We'd select funding. There we are. Gives us the data frame. So this actually keeps it as a data frame, but we now just have the funding column. You may want to put 2 in here, so you may say, and there you go, you got 2 of them. The order's now swapped because that's how I put them in here. So that's what select does. So select, you see it's keeping all 140 rows, but just picking out the columns that we want. Now that we've done that, so say we want to do some chaining, we want to use the arrange. So this is going to sort our data frame. So say now we want to take summer, select these 2 columns, and then sort it by funding. We would write arrange. So pipe, well, again, we're piping in our results. So whatever we had before, we're just going to pipe that in. I'm going to arrange, and then you just specify the column that you want to arrange by. So you run that, and this is what we have here. Now, one thing to always remember about arrange is that it always orders stuff in descent. It orders numerics in ascending order. So you see we've got the funding zeros all here, which you might think is kind of annoying or counterintuitive. To swap it out, you can just put minus. So essentially you're just arranging by the negative, which basically just means you go the opposite way around. So you see now we've got the biggest ones there. Alternatively, you can just do desk like that, which is just short for descending. Same thing, whichever's more, whichever you think is more intuitive. Next, next we'll look at mutate. So this is the 4th verb. So this is what we do for adding. We'd use a mutate when we want to add more columns in. So we want to almost alter our data set and create a new column. So an example here, maybe that we take the summer object and then we create this new column. I actually always like to put on my new columns in quotes just to sort of remind me that it's a new column, but that's up to you, you don't have to. So we're going to say we're going to mutate summer, and what we're going to do is we're going to add a new column, which is this, and then we put an equals, and then we say how we're going to define it. So we're going to define the funding rounded column, which is our new column, by basically saying we want funding, but to 4 significant figures. What you can then do, which is quite nice about mutate, so you could just, let's just make this a little bit more clear. So you could just put the last bracket here and just say, why is that not, there we go. And so you can see that it would add the new column. So we've now got the same number of rows, but just an extra column, which is funding rounded. You could then say, all right, what I now want to do is I want to create another column based on funding rounded. So you could pipe this data set into another mutate and then say define it. But what's actually quite nice about mutate is you can actually just, you can put different mutations in just separated by a comma, and that's the same as piping it in to a separate mutate. So say you wanted to create this new column and then create funding multiplied column, which is based on a column that you've just created. You can actually do that without piping it into an extra mutate. You can just put it in as the next argument. So separated by a comma. Oh, we've got an error. One too many brackets by the looks of things. Yeah, and so there we are. Two new columns. So you can see what's quite clever about this, I think, is the fact that you're using a column that you literally just created for your calculation. So it's not even like you need to run this thing first and then put it in. You can just we can just use a column that we literally just created, which I think is quite nice. So that's mutate, adding new columns. Next one is summarize, I believe. Yes, summarize. So have we got a better example of summarize? Okay, maybe not. All right. So summarize is for getting summary values of your data frame. So I'm going to use the pipe here. Let me know in the chat if you guys think that we're using the pipe here is instructive, or you think it's actually just confusing, because I'll stop or continue depending on what you want. But currently I'm going to use the pipes because I think it's good to use. So we're going to pipe this in to summarize, and then we say what summary value we want. So let's just remind ourselves what summer looked like originally, just by highlighting it and running it. Let's say we want to find the mean of funding. So we'd say summarize. It knows that the data set we're going to be summarizing is summer because that's what we're piping in as the first argument. And then the second argument will be whatever summary values we want. So I'm going to name my summary value, let's say, call it mean of funding. And then I'm going to define that as the mean of the funding column. So you see here, this is just not very exciting, just a single value because that's all we expect. In that sense, summarize isn't that exciting. Mildly more exciting is you can do two different summary values in one. So you'd say, I want a summary of the mean of funding, but I also want, say, the standard deviation of funding, which I'm going to call this, which is obviously a terrible name, but that's what we're going to go for, standard fund. And we're going to say that is the standard deviation of funding. And now we've got two summary values. This is almost like the sort of the base way to use summarize. This is not actually what I would use it in most sense. Normally for me, I think Joe would agree, you use summarize after having grouped your data. So we're going to actually show you a function here called group by, which I think is kind of self-explanatory. So we're going to take summer, pipe it into group by, and then we have to choose a variable that we want to group our columns by. So say we want to group by location. Now this is what we get. So when you actually group by something using this group by function, which this is all part of dplyr, by the way, all still part of dplyr, you still have the exact same data frame coming out. So this is just the same as summer. The only thing is we've just added this little bit of extra information, which is that we now group by location, but nothing's currently changed. However, now when we use our summarize, so we take our grouped data frame and we pipe it into summarize, and we say mean, let's just copy this line. So we say that the mean of funding is going to be mean funding. Now, instead of performing the summary on the whole data frame, it'll perform it on the individual groups. So you see now, for each different location, we have a mean of the funding. So you can see this is the mean funding for Athens, Beijing, LondonR. And this is where I really think dplyr is almost at its most useful. So often when you're doing data analysis, you want to find out, oh, how does the mean vary for different groups? And the easiest way is always to use group that and then summarize. And that's why I think it's really useful. And just as before, we could always just add in an extra column if we wanted. So say we wanted the standard deviation as well. And that is what we get. So I think these are really sort of neat little functions that work quite well together. Yeah, and that's the majority of dplyr. Just flick back, see if I missed anything out. But I think we're probably good. I think we're good. So that's dplyr. So filtering for rows, selecting for columns, arranging for ordering, mutate, add new column, summarizing for creating summary values. Now dplyr also has joins in it. So this is for where we'd like to join two data sets together. I just realized that picture has come out really, really grainy. So it might be worth actually just Googling that. If you want to see the dplyr joins in the Venn diagram for how they work, I think it's kind of a lot more instructive than me trying to explain it. But I'm going to give it a little go at explaining anyway. But yeah, have a look at this Venn diagram if you ever want to use them. But yeah, we use joins to join two data sets. So I think maybe the best thing is actually just to give an example straight away with this actually. Yeah, let's do that. So let's look at what we've got, summer, and what were the other, did we get that years data set? So this is the years data set that we made in our tribble earlier. So this one just here. So you can see again, we've got location and other stuff like that. So that's summer, that's years. So we want to join these, we might say full summer. So again, we're assigning whatever we're going to do to an object. We do a full, what's called a full join. So you can see it popped up there saying dplyr, just so you know, just sort of remind you it's part of the dplyr package. And then we define which of the data sets we want to join. So summer in the first argument, and then years in the second. That runs. Now this is almost the clever part. So what is really clever about dplyr full joins is we haven't even told it what to join on. It has just recognized the fact that summer and years both have a column named location, and it's looked at them and just gone, okay, right, I assume that's what you mean to join on. You don't have to do that. You could try and join on different things. But yeah, location is what we want to join on here. Alternatively, to actually to say specifically what you want to join on, I'd say you use the by argument. Just say by equals, I think this is how you do it, just by equals location. And that's exactly the same. Now to see what we've actually got out of this, I will run full summer. And so what you can see is what it's done is it's joined the two data sets. So where, for example, we had here, we had in summer, we had archery in Sydney, had 0 funding. Now it sees that because we're joining on location, it sees that we've got Sydney here and it goes, ah, we've got Sydney in years. Therefore, I'm going to basically just add this column information. And so that's what a full join is doing. So we just get that information added down here. And so you end up with this bigger data set. Now, a full join makes sure that there's all the rows from both. So it will take all of the rows from summer and look at the location and then join on the extra information here. But it will also look at all the rows from years and make sure that there's that it can find values from summer as well. But here they're already specified, so we end up just with 140 rows. There are different types of join as well. So there is like inner join, left join, and right join, which just define which of the data sets you want to keep the rows from. So from a left join, for example, would just make sure that you keep the rows from the first variable you enter, just because it's on the left. And then a right join would do the opposite of that. That's joins, very useful. Maybe worth reading up on documentation if you want sort of further information. But I think it's just mostly just useful just to know that you can do these joins. Sometimes it's worth just looking at the dimension of your data frame, trying a few different ones and looking at the dimension of the output and saying, is that what I expected? Alternatively, yeah, there are these Venn diagrams, which I think are kind of helpful when they're a bit less grainy. Cool. Now we have an exercise. So obtain all the records corresponding to females. So remember our dplyr verbs were filter, select, mutate, summarize, group by, and arrange. Sort the initial data set by descending test score. Can you guys see you haven't got faces in your way, have you? Because I've got Zoom heads.
No, it's looking good.
No, looking good, okay. By descending test score. And then find the mean test score for test A and test B for each course. So if we're doing it for each course, we may have to do some sort of grouping there. Have a go. I'm not actually planning to put on any elevator music this time, so it may just be every other one. But yeah, have a go. Let us know if unless Joe wants to pipe up. But if not, yeah, let us know if you have any issues in the chat. please message us. Or if you're just done early and you're bored and you want to move on, let us know as well, and we'll get moving.
Hi, Khaled. Just in your question about the gather function, that's actually the exactly the same as pivot longer. It's just the kind of a slightly older version of that same function. So gather is the same as pivot longer.
Yep, no difference there. Literally, the only thing is that if you try and use gather, it'll basically just say, please use pivot longer. That's it. But you don't have to. You can ignore it.
Yeah.
If you prefer it.
Oh, we got a poll.
Who did that? Was it you, Joe? Or was that Laura?
To me, I think it was Laura.
That was me.
Oh, off. Can we? Is there an option for on, but like a lot quieter?
I think
I was getting private messages saying this needs to stop being this loud.
I mean, I wasn't doing the exercises, but it was nice having it a bit quieter in the background. There's a resounding off. It depends what kind of music we have, I guess.
I don't know. I think the ons are coming back.
Okay, so half the people hate it, half the people like it.
Just like Marmite.
I thought you were going to say Brexit there, but oh well. How's everyone getting on? Let us know in the chat if you're bored and want to move on, or struggling and want to move on. I'll give it a few more minutes for now, though. Right, I think probably going to move on now. Don't worry, obviously, if you haven't got everything. The exercise answers will be on the GitHub page, so you can always get them afterwards if not, if you want to go through them. But I'm going to go through them now anyway. Just flick over to RStudio. So first question, obtain all the records corresponding to females. So where are we? RStudio. So we have our uni results, which looks like this, and we want all the records corresponding to females. So we are basically reducing the number of rows here because we're only taking the rows where we have females as the gender. Yeah, so look across the columns and it's the gender column that we want. So we take our uni results, we pipe it in to filter, and then the second argument, which now looks like the first argument because we've already piped in uni results, is going to be just our condition. So we're going to say gender. You notice it comes up here already because it already knows what the columns are. So gender, like that, equals, I probably should have mentioned this before, actually. I don't know if I'd mentioned this properly. When you do, no, I didn't because I used in, didn't I? When you use, when you want to specify a condition and you want to say something's equal, you need to make sure you're using the double equals. If you do a single equals, that will sort of work the same as this assignment operator. The same as Python, if anybody uses that. In R, we always try to use the assignment operator to sort of avoid this confusion because we use the double equals to sort of specify a condition. So we're not saying we want gender to be equal to female. We're just saying if it is, then that is the row that gets returned, right? So it's not just, you know, we're not assigning gender to be female. We're just specifying a condition, which is why we need this double equals here. So we're going to say gender equals female, all caps. And you can see that's filtered. So of the 100 rows, we're now down to 56. Next one, sort the initial data set by descending test score. Cool. So let's say sort the initial data set it did, right? So we'll start again with uni results. And this time we're going to pipe it into the arrange function. Did it say by descending? Yes, it did. So we're going to use desc and by, why do I keep having to go back? Test score, is that even a thing? It's not got two scores. Okay, question doesn't quite make sense. Let's say we're going to sort by test a score, just make life easier. And you can see there it's done it. Alternatively, we can use just the minus instead, which I think is slightly easier to do that. So that was filter followed by arrange. Next one, find the mean test score for test A and B for each course. So this is going to be a group by and then a summarize. So if we're saying for each course, and we're going to be doing summaries on each course value. So that means we need to group by the course value. So we're going to do uni results, group by, and then course. So that just gives us the groups, as you can see here. But then we're going to take that and we're going to say okay, so now we need to find the mean test score for test A and B. So we're going to say, all right, let's say, so we're going to summarize for each of the courses. Mean A, I'm going to call it, equals mean of test A. Mean B equals mean of test B. And remember, this is group, so it'll do it for each one. And there you go. That's what we've got. So this is our summarized table. Cool. So hopefully you all got that. If not, then please follow. Have a look at the script later, because I think that'll be helpful. I think back to you now, Joe, I believe. So I'll stop sharing my screen and hopefully hand over.
Yeah, perfect. Cheers, Andrew. Cool. So let me share the screen. Fantastic. Okay, so Andrew's really well. He's introduced those kind of dplyr functions for kind of working with our data frames. Sorry, working with our tibbles. I'm still getting that wrong. But kind of how we can kind of like create some kind of summaries and filter our data. But now we're going to kind of take a kind of aside and look at how we can kind of manipulate different types of data. Now this might not be too obvious at first, but we're going to be looking at kind of 3 different types of data that we kind of might come across inside our tibbles. The sports, this column of sports and this column of locations. We've kind of been treating that as, we haven't really looked at what kind of type of data that actually is, but we would call this kind of data categorical. And what do I mean by categorical data? Well, you might have heard of it by some other names, such as a factor. And this is what we're going to be kind of converting these categorical data types to. We're going to be converting them to factors. So a factor is basically just a column of data or any sort of kind of subset of data where we have kind of a set of unique values that that factor can take. So for example, in the locations we had Sydney, Athens, I can remember Beijing, for example. These are all kind of individual levels of this factor. And when we kind of create these factor variables, these factor kind of data, it's kind of telling R that actually all of these columns, all of these observations where it's Beijing, well, they all kind of relate to each other. They're all exactly the same kind of level. And similarly for Athens, they all kind of relate to each other. And so this just kind of allows R to interpret these factors as the same thing. And to kind of work with these factors type data, we're going to be using a package called forcats, which is either, I think of it as an anagram of factors, or you can think of it as forcats, 4 categories. I think it's just a really well named
I never
package.
knew, actually. That's...
Did you not? Yeah.
No, I never knew it was an anagram.
Yeah, a nice little badge there in the bottom as well, if you like your stickers. Anyway, but what this forcats package allows us to do is kind of work with our factor variables and kind of the 3 of the things that is kind of most common. It allows you to kind of change the names of the factors. So if we had Beijing, we might want to change that to China, for example. That would, this factor forcats would allow us to do that. We might want to group levels. So for some reason, we might want to kind of group, let's say, London and Athens into Europe, and so we could group those 2 kind of levels of the factor into 1. And finally, it allows us to reorder levels. So perhaps we might want to reorder our factors. I think we're actually going to look at this in the example. Reorder our factors based on another value in our data. And this is particularly useful when we're doing plots, which we'll look at in the next chapter. When we're producing plots, it'll be particularly useful. Cool. So yeah, well, here we go. Like I said, so this is kind of a plot of what have we got here. We'll be looking at how we kind of make these sort of charts in the next chapter. but we just have the kind of the three locations, and by default, R is kind of done this alphanumerically, so we have A, R, and S. However, this kind of bar chart doesn't look very nice. We might want to kind of reorder these factors into a slightly nicer format, so that when we kind of apply this code, which I'll kind of show you in a second, we can have a plot that looks more like this. So where we have kind of a decreasing bar chart, it's just more aesthetically pleasing. So we're going to use for caps to kind of manipulate our data and to make the factors in this ordering. Cool. So what have we got here? So I've kind of copied where Andrew was going through a dplyr, but I've just created this no funding data frame. All this is I've taken the summer variable and I've just taken all the values where the funding is equal to 0. So let's really quickly see what this looks like. No funding. Okay, so we can see here, we just have all the sports and locations where there was no funding for load in forecasts, like so. And now let's kind of work with this. We're going to perform quite a few steps before we kind of mutate our factor. So I'm just going to kind of go through those first with you. So we're going to start with our data frame. Let's use our old pipe. And firstly, we're going to just create a really quick count of our of the location. So we actually haven't seen this count function before, but all it does, it literally just performs a count of the number of observations, number of times that instance occurs. So if I just run this code like so, we can see that we get this value n, and you can see that we actually had 11 sports in Athens where they received no funding. So this count function is just a really nice helper function that you might use. Next, we're going to left join on the years. So this years data frame, years tibble that Andrew's working with before to join onto the summer data, we're going to use it again here to join onto this data set. And we're going to use a left join here so that everything in no funding is just going to get these year, month, and day columns kind of appended onto the side of it. And finally, we're going to mutate. And this is when we're going to use our for cats function. So we are going to overwrite our location. So I've specified location here. Let's put it in quotes, as Andrew did, just to kind of break it up so it's more easily identify which column we're creating. And we're gonna, so currently these factors will just be ordered alphanumerically, like we saw in the plot. It will just be kind of Athens, then Rio, then Sydney. Let's try and reorder this based on this variable n that we have here. And to do this, we're going to be using a function called fct reorder. Now, when I start typing fct, you'll see we get all of these recommendations for all of these functions we can use. And this is kind of all the functions in the forcats package. So every function in forcats starts with this fct. But we're going to be using one of these. We're going to be using reorder to kind of reorder this factor. What do we need to supply to this function? Well, firstly, we need to supply the factor that we actually want to reorder. So this is going to be, again, we're going to specify our location column because we're reordering this column. And then secondly, we want to define the other variable that we want to reorder by. And so in this example, we're going to be reordering by the year column. So what does this mean? Well, this means that instead of ordering alphanumerically, so A, R, and S, instead it is going to order by this year column. So we're going to start with Sydney, which is 2000, then we're going to go to Athens, and then we're going to go to Rio de Janeiro. So this is a really quick way to reorder our data. So when we run that, we actually don't see any differences. Our data still looks the same. However, if we were to go away and plot this, which, as I said, we'll kind of look at how we kind of plot our data in the next chapter, then we will see the real value of reordering our factors here. So yes, that's what we have to say. I think, Andrew, you taking on the next kind of two data types that we have to look at. Yeah, fantastic. I'll share my screen and pass over.
One second. Apologies, everybody, for the constant changing of screens. Hopefully that's all working fine. You can see my RStudio let's go back to the presentation actually from current slide. Yeah, so we're still on that. We're still on the transform bit of our data. So we're still transforming stuff. You just saw how to sort of rearrange factors. Now going to be looking at working with strings. So as I mentioned before, a string is literally just a bit of text. So in R, that's represented by putting something in quotes. That can be sort of double quotes, apostrophes, or yeah, just an apostrophe. So like a single quote doesn't really matter. String R is one of the main packages that you use to work with strings. There were previously quite a few different functions from other packages that you could use to work with strings, but they just weren't very consistent in what they did, what the output was, and the way you sort of specified what you were trying to do. The thing with string R is it makes them all very consistent, which means working with strings is a lot nicer. So when you have, say, for example, a data set that's got loads of character columns which are just strings, then it's just be useful just to use sort of string R throughout. Type of manipulations we can do concatenation, so that's just joining two strings together. Pattern search and replace. So yeah, might have a sentence, my name is Andrew. You might search for the pattern name and replace it with, I don't know, birth name. And then you get my birth name is Andrew. And then subsets. So you might just say, I just want my name is, just like that. I think I'll give a bit of an example actually as well. So I'll flick over to our studio. So as you can tell, I'm copying this in from somewhere else just to make it a little bit easier, but I'll just explain what we're doing. So, so remember we had the summer data set. The function we're going to be looking at here is str to upper. So if you look at string R, which is the package, you can do that by doing string R : : This will show you sort of all the objects within the package. Most of the functions start with string underscore because you're essentially just doing something to a string. So this one is string to upper, which just creates everything to uppercase. So here we're going to use a mutate. Now what we can do is you can say, let's call it upper location is our new column in summer caps. And so we just put inside the column that we want. So you could use it on just like a particular vector, so string to upper, and then say, okay, we're just going to use summer location, and then it would just print them all like that. Or if you're doing it within a mutate, it already knows that location is in reference to the column from summer, because this is all inside a mutate. So here, when we're trying to sort of add it as a new column, we don't have to say summer and then use this little dollar to extract it. We can just specify location and it knows that we're talking about summer. So here we're going to mutate, use our string to upper, and let's have a look at what we got. So this is summer caps. And so you see it's just, as you might have expected, it's just moved everything to uppercase. I don't know if I mentioned this before or not, but with mutate, if you want to overwrite a column, just use the same name. So here I could just say location equals that. And you see it's actually just overwritten this one instead. So normally when I'm overwriting, I just keep it as the like that. And if I'm adding a new one, I go like that, just to sort of make it easier to myself. But again, you don't need to do this. But again, that's more dplyr stuff. The string to upper function is the string R bit that we're actually looking at. Let's see if we can get something a bit more. Actually, do you know what? I'll move on to lubridate first, and then I'll do an example with both. I think that's an easier thing to do. So let me just quickly flip back to the PowerPoint. So that is string R, which I will come back to. Lubridate is a package that is for use with dates. Basically, often you'll have dates that are just written as characters. So it will literally just be a string just in quotes, and it will have a date, but R doesn't actually know that it's a date because, well, how would it? It's just written as a character. So lubridate is a really helpful package which helps convert things into the specific R date format. And it uses these functions like YMD, which is just year, month, day, year, all just like that, which is just how you want your date specified. So I'll give a little example just to make it a little bit more clear what I'm talking about. So let's say we have summer here. Remind ourselves, looks like that. And then we'll say we're going to add a new column, so that will be a mutate. And then actually, what's the best way to do this? Did we add a date column? We did. Right, okay, I see why I'm expecting something else. Apologies, 1 second. I think I forgot to join. That's why. Did I call it full summer in the end, the join? Yes, I did. Apologies. This is what I'll be working with, not the original summer. So take full summer. Now, what we want to do is we want to get a date for the start of when the Olympics were. Currently, we have a year, a month, and a day. They're actually currently in the format of doubles, which are basically just a numeric type. Double just means you can have a decimal point in it, but basically it's just a numeric. But what we want to do is we want to actually turn that into a date. So the first thing we're going to do is take, we're going to use this string C function. So I'm hoping most of you are familiar with the normal C function, which just turns things into a vector. So say you might have C1, 2, 3. Run that, just gives you the vector 1, 2, 3. So that's your normal C. Str-C is almost just like combining vectors together, but sorry, combining strings together. So what we're going to do is we're going to add a new column using the mutate, finally, and we're going to call it date. And we're going to say date is the string concatenation of year. So the year column, the month column, and then the day column. That will literally, if you just run that, that will literally write it out actually as, actually should I just run it just to sort of show you? It just completely just concatenates them like that, which is not really what we like. So what you can do is you can specify in string C a set argument, which describes how you want to separate the things that you're concatenating. So say we're going to separate them here with a dash, which is generally what people use in R when they're talking about dates. They use dashes. Whoa, what have I done there? Oh my God, what have I done there? Apologies. Run that. And now you can see that they're individually separated by a hyphen, which is a lot nicer. So that was string C. Still, however, you'll notice that this is written as a character. So this is still not in date format. So this is where we actually use lubridate now. So we can either pipe this into another mutate to sort of alter this date column, or alternatively, as I sort of mentioned before, we can actually just separate it by a comma and put it in the same mutate call, which is what I'm going to do. So I'm just going to overwrite date. I'm going to say date equals, and now this is where I'm going to use one of my functions from the lubridate package. So the function I'm actually going to use is YMD, because our date current format, these character vectors are in year, month, day format. And you need to basically let it know that, because you may, for example, end up having a situation like this where, okay, it's obvious from here that 15 is not the month, but if you just had that, for example, you don't know. So you need to specify exactly what it is. And that's what we use this lubridate function for. So we're going to say year, month, date of our date column. And we have an error. Have I libraried in the Tidyverse? Oh, I think it's because I accidentally restarted my session by keyboard mashing earlier. Maybe that's why. Input date is YMD.
You need to do library lubridate. Do library lubridate.
Apologies, yep.
Yeah.
Yes. So as I mentioned before, Lubridate is sort of seen as one of these Tidyverse packages, but it's not part of the core one, so it's not instantly installed. Which is not, sorry, it is instantly, but it's not instantly loaded in when you library Tidyverse, which is why I then had to library Lubridate as well. So basically the functions from Lubridate weren't ready for me to use straight away. So library it in if you haven't done it already. And now we can use these functions. YMD actually knows what we're talking about. So apologies for that. And you can see now that actually it's been put in as a date format. So it actually knows that this is a date. This is actually really useful because the main thing I think dates are actually useful for in R is that is when you're plotting like a date on an x-axis. It basically understands how to do that. It's not going to say, oh, how do I interpret this character of 2000 dash this? You know, it understands what it should look like. It sort of plot time series a lot nicer. So that's why it's useful to have that in that format. Just flip back to the PowerPoint. That may be all I want to talk about for now with Lubridate. You can't, Lubridate does also have some arithmetic as well. So I think there's is it a day function? So say for example, I looked at, what's the best way to do this? So I had this string and then I turned it into, I used YMD to turn that into a date. What's nice about Lubridate is, so say we're going to call this my date, is you can do arithmetic with dates and times. So you can say my date, I think this is how you do it, plus day 3. No. Plus 3. And it's added on 3 days. So it's little things like that. There are ways to add on different amounts, different like units of time and stuff like that. I can't quite remember off the top of my head, but they're all contained within the Lubridate package. Cool. So yeah, extract elements from date, arithmetic, time and dates. We've done that. And then yeah, this is just sort of, I'm not going to actually run the code for this plotting, but this is kind of what I was talking about when I say it sort of understands dates. So you can see on the x-axis here, you would have just put in a date format, and it just understands that they're all in a row, which makes plotting a lot nicer. Now on to another exercise. So 1, convert the test variable to a factor, renaming the values to A and B. Then make sure that the graduation date variable, remember this is all with the uni result stuff, make sure the graduation date variable is indeed a date object. So when you look at the variable, you should see whether it's a character or a date, assume it will be a character. Alternatively, you can run this class of the extracted vector, so uni results extract graduation date, and that will let you know. But yeah, try and convert that to date with Lubridate. And yeah, as always, let us know if you have any issues in the chat. So I just seen your question, Osvaldo. What's the meaning of the double double again? Why is it equal to numeric? So they're actually almost like, so in R there's different classes and then there's subclasses within them. So numeric is almost like the overall class, the higher one. Numerics, included in numerics are, say for example, integers and doubles. Doubles are just I'm trying to think if there even is another one. All I can think of is integers and doubles. But yeah, basically a double is something that allows a decimal point. Just going to give it about 1 minute and then go through. Cool. Right, I think I'm going to go through. Hopefully you guys are nearly done-ish. But yeah, I think it's worth going through now. Just going to flip over to our studio. Can you guys see our studio there?
Yep, got it.
Yep, cool, brilliant. Might look a bit bigger. I did change my font in the break. Cool. So the first question, let's have a look. So convert the test variable to a factor, renaming the values to A and B. So this is what we currently have. You can't actually see it because the tibble's not printed all the way because I've increased my font. So this is what we have. Yeah, you can see the test variable. We have test A score, and currently it's a character from that CHR. So what we're going to do is we're going to pipe it into a mutate because we're going to be changing this column. And so we're going to say test equals factor. Is it factor? What is it? What is the function again? I've forgotten now. I think
Yeah, factor. Yeah.
Factor. It's weird that it's coming up with base. Yeah, I guess that's right. Factor test. And we can see what that is. So that's exactly the same. The only difference is now that you see that this is now properly treated as a factor. It might not seem like there's much point in doing that, but actually there's a lot of situations in R where if you don't change stuff to factors when they should be, other functions just won't work properly because they kind of expect you to have. It's a really annoying little thing that you just basically just need to remember. So now that we've changed it to a factor, the next bit of the exercise was to rename the values to A and B. So we're going to do test equals, and now this was a tough one because we didn't actually go through this function. So you could have maybe found it in the help files if you guys know how to access that. But to be fair, we didn't go through it, so this was tough. The function you actually want here is factor underscore recode. So this will, yeah, I mean, it will recode your factors, so you can change your factor from saying, oh, the factor of test A score, we want it, say, just to be something else. So we still have to pick the column that we want, so factor recode of test, the test column, and then make this a bit smaller, and then we say, okay, so we want A to be equal to test A score. So we're defining our new variable A, and we're going to say it's equal to that. and then B equal to test B score. And unless I've made a mistake, hopefully that will work now. So I just put an enter here just because that was slightly run off the page so you can see it a bit better. So yeah, we're changing that to a factor and then recoding to what the things mean. So you can see that's now worked just like that. Next bit of the exercise. Make sure that the graduation date variable is indeed a date object. You can check this using class of uni results. So, I mean, we can already see it's a character just from there, but just to confirm to everybody, we can do that. Graduation date. And you see it comes out as character there. We want to convert it to a date. So we have a look at it and we see what format it's in. We see that it's year followed by month. I can't actually tell instantly, but I'm pretty sure that's year followed by month followed by day. And so let's just do it to what we already had. So just pipe it into another mutate, which we don't have to do. We could just put it in as an extra argument, but I think it's more clear to separate like this. So pipe our result, and we're going to say that graduation date, we're going to overwrite it with year, month, date, year, month, day, sorry, of graduation date. And we see now that that's in a nice date format. So hopefully everybody got that. Bit of a tough one with the factor recode. But yeah, it's worth looking through some of these factor functions whenever you need one, or looking up the help files. Yeah, I think that'd be useful. What are we on to next? Yeah, so that's really the end of the transform section. So we're changing stuff to dates, changing strings around, filtering, summarizing, that sort of thing. I think you're doing this chapter now, Joe, am I right?
Yeah, absolutely.
Right,
yeah,
I'll
go on to visualize.
sharing.
Cheers. Cool. Okay, cool. I realize we're kind of time's moving forward as it always does. So we'll kind of, I think we'll have to kind of go slightly quicker for these last few chapters, just try and squeeze them all in. So we might not have time for an exercise on these last few, but I'm sure we kind of have the solutions and the exercises on that GitHub page. So if you want to do it in your own time, then that's all there for you to do. But we'll still go through these really briefly at the very least. So visualize. So we've kind of transformed our data. Now we're ready to kind of have a look and see what our data actually looks like. What we're going to be using to make our visuals is a package called ggplot2. Not the nicest name in the world, but GG stands for Grammar of Graphics, which is a book. It's kind of based on this idea of how graphics have a kind of a common grammar. You don't need to worry too much about a kind of theory. And the 2 is because there already was a ggplot. So Hadley Wickham, who wrote ggplot2, had to go for ggplot2 rather than ggplot. So that's why. So ggplot in itself is a absolutely massive package with a huge scope of what you can actually use it with, do with it. So we're really going to only breaking the service of what you can kind of do. We're going to be looking at a couple of plots. I think we're going to be looking at a line chart and a bar chart, just some really kind of simple examples, but hopefully will kind of give you enough of a feel for how kind of you can work with ggplots. And so we're going to be using 2 kind of types of functions in this. ggplot has like a number of different functions that you can use, but we're going to be using 2 kind of special types of functions. The first is called geom. Geom stands for geometry. And when we use these geom functions, that is just the type of chart we want to produce. So we're going to be using a line, so geom line, which is going to be producing a line chart. And then we'll look at another chart, we'll be looking at geom bar, which will produce a bar chart. And then we'll also look at using some other functions for kind of controlling the titles and the labels for our plots. So the first plot we're going to make, this is kind of the code we'll kind of look at. We'll go through this line by line, so don't worry if it seems really confusing at first. But we're going to be aiming for a plot that looks something like this, which is slightly messy, but it will give you enough to understand the theory of what's going on behind the scenes. So let's try and make this plot in R. Okay, great stuff. So I'm going to put ggplot2, and this is, I'm pretty sure it's one of the core Tidyverse packages, so you won't need to load it in, but yeah. So ggplot. So the first function that we always start with our ggplot functions is this ggplot function. This is kind of our base layer, and if I kind of execute this on its own, we can see that nothing really happens except that we've got this kind of window in our bottom right is kind of turned grey, and we can see there's something there. So if I get rid of that again, you can see it's white. Let's execute that ggplot, and now we've got a grey background. So that hasn't done an awful lot, but we can tell it's done something. Something's going on there. Cool. The first thing I'm going to do for this ggplot function, as with all our kind of tidyverse functions, is provide the data. So we're going to be using this summer data that we've been kind of looking at so far, and we're going to be kind of visualizing this. Again, if I kind of run this, again, kind of nothing's going to change, but we're still going to have this grey box in the bottom, so nothing too exciting yet. Cool. The next thing we're going to use is an argument called mapping. And we're going to use this function to tell the ggplot which variables in our summer data, which variables we actually want to use in our plot. So we have, what do we have? 3 variables. We have sports, location, and funding. And we're going to be using these 3 variables to produce our line plot. And we need to specify these with this mapping argument. And there's actually another kind of key function. This might seem quite strange at first, but we need to wrap all of this, what I'm going to show you next, in the function called AES. This stands for aesthetics, and this is just kind of how we control this relationship between the variables and the visual that we produce at the end. So I'll show you what this we're going to look like, and hopefully this will be slightly more clear. So firstly, we're going to provide an X variable, which is going to be our X-axis, and we are going to provide the location as our X-axis. So that's going to be on the bottom of our chart. Next, we're going to specify for our y-axis, we're going to use the funding variable. So that's going to be going up on the left-hand side. So if we, let's leave that too. And then we're going to add 2 extra things on here. We're going to color by the sport variable. And we're also going to group by the sports variable. This will become clear exactly what this is doing, but this will be changing the kind of coloring of our different lines. Cool. So this is kind of our base function set up. And if I execute this now, you might see that we've got some stuff starting to appear on the little window down here. So we can see on the x-axis, we've actually now got our location. So because we've defined this x aesthetic, we now have a location on the bottom. And similarly with the funding, we have funding on the y-axis. But we don't yet have our color or our group aesthetics defined. So we haven't seen them yet, but we will see them soon. So we've kind of got our base level. Now we're kind of ready to use one of these geom functions, one of these geometry functions to kind of tell ggplot what type of chart we want to produce. So to do this, I'm going to be using slightly different to a pipe, but very similar. We're going to be using an add, a little plus symbol. And I'm going to go on to the next line after using this add function. And I'm going to call this function geomLine. So I'm going to be looking for a line geometry. And now when we kind of execute this all together, so we're going to execute our kind of base ggplot function and then the geomLine on top, we should see some kind of mapping of our data. So let's kind of make this slightly bigger. And we can see that we have some slightly not too attractive, but we have a plot nonetheless of our data. I'm not sure why it looks quite off. But okay, we're going to have us work with this and continue anyway. So that's kind of our basic line chart. The next thing I'm going to show you really quickly is how we can control kind of the axes, labels, and also kind of add a title to our chart. Something kind of basic things we might want to do. So first, we're going to add a title, and to do this, I'm going to use a function called ggtitle. And all we need to do within this function is just to specify a string that's going to be our title. So let's put in funding by sport over summer Olympics. And now we get this nice little title at the top. We can also, as I mentioned, change our axes. So I'm going to use an xlab function, and this changes the label for our x-axes. And let's change it to the location of the and now we're going to get a location of Olympics spelled incorrectly, but nonetheless it's there. We could also use a ylab function, which would do exactly the same. We don't need to do that here, but we could do if we wanted to. Okay, and that's kind of how we've produced this chart. for our data.
Sorry, Joe, just a little thing. Good mention from mBankhead that we've actually, it's because you've included the total. I think earlier we were maybe supposed to delete, I think it's just the last row, which has a total column.
Oh, you're right.
Which is why you're getting this massive line on top. So cheers for that. Cheers for putting that in the chat as well, because I would not have spotted that.
Let me comment this out and then run everything, hopefully.
Just make our plot look a lot nicer, I think. But yeah.
Okay. Okay, I just haven't run that. Okay, cool. This should work. Hey, there we go. Cool. Thanks for that recommendation. Cheers. Yeah, so we've kind of filtered out the data somewhere. I must have just not executed that. Okay, so that's a really basic line chart. Next, we're going to show you another basic chart. Let's produce a bar chart instead. So let's see what we're kind of aiming for first. So G on bar, we're going to produce a chart that looks something like this. So again, we're going to start with very similar. We're going to start with our ggplot base function. Again, let's use summer as our data frame. And again, we're going to use this mapping argument with this aesthetics function. And then in this aesthetic, we're going to define all the variables we want to plot. Let's look at the chart, what have we got here? And if you look, we've got a kind of location on the bottom. So we're going to ask me our x-axis again. But on the left, we've actually got no kind of variable. We've just got the number of sports in there. And if we look at our data, our summer data, we can see that we don't have no kind of count for variable to include on our y-axis. So we're going to do something clever here. So we're going to do, let's put x as location. But this time we're going to use just g on bar without any y specified. But this g on bar function is quite clever. ggplot has a number of kind of functions called stat functions, and these will perform kind of some statistical summaries, some statistical transformations of our data. And this kind of goes on under the hood without you realizing. And what these geometry functions do is they make use of these transformation functions. And so what's going to happen here is, because we've used this g on bar, this kind of looks at our data and it just creates a count of all of the variables that we've specified as our x-axis. So now, simply by executing this code, we're going to get a count for each of these locations. And I've used the wrong data, apologies. We should have been using no funding, which is what we defined earlier. There we go, that looks slightly better. Now we've this g on bar has performed a statistical transformation just to count the number of observations where there was no funding in each of these locations. Yeah, and we could, if we wanted to, add some titles and some labels in much similar way as we did with the line chart. Okay, great. I don't think we have time for an exercise, so as I said, we're going to gloss over this and kind of move on to the next chapter. But I think we've kind of gone through the bulk of what we wanted to so far. Okay. The next chapter we would be looking at modeling. This is kind of another massive chapter in of itself. And we're actually not going to go into too much detail about how we would use this, how we would use modeling in the Tidyverse. But if I can, there are kind of a few functions, a few packages that kind of point you to if you are kind of interested in this modeling. And those are firstly LondonR and secondly Broom. LondonR allows you to perform all your kind of your fitting of models, and Broom is when you've kind of fit those models. You're allowed to you can use Broom to kind of make those results of your models much more tidy. So we're not actually going to go through this modeling, but kind of if you are interested in this, I think there are some code I think that might be included in the scripts. So if you are really interested, feel free.
Sorry. No, I was just thinking, do you think it's worth maybe just showing the linear model, just because it's so common and probably pretty quick? We could maybe just do it for 30 seconds. I don't know. Sorry, I know we said we wouldn't do it, so I'm sort of throwing you under the bus here.
Okay. But, yeah, let's have a crack. Okay. Yeah, I can.
It's so useful. Something. You may as well just sort of whip a random one and just show what it looks like at least.
Let's show a linear model. Yeah. So we'll show a linear model. This actually isn't in the Tidyverse, so I guess we're going slightly out of scope of the Tidyverse functions, but it's fine. And let's kind of fit a linear model. So a linear model, we use this lm function. standard linear model. And firstly, we kind of, again, we're going to define firstly a formula for our model. And we do this in a specific way. So we define the variable that we want as our kind of y model, as our, we're going to have to, as our independent variable, the variable we're trying to predict. So let's use, sorry, I'm thinking on the spot, let's use the data from the empty cars. If you know what this data looks like, it looks something like this. Let's try and project the miles per gallon, and we're going to use the cylinders and the weight to try and predict this. So in this formula, we're going to put on the left-hand side the variable we're trying to predict. And then we're going to use this little twiddle again that we've seen before, this little tilde. And then on the right-hand side, we can provide the formula that we want to use to try and predict this. So let's do cylinder and weight. And when we run this, we've kind of, this is going to fit our model. And so if I save this to object, my model, then we can kind of do some kind of cool stuff, such as look at a summary of this model and see some kind of some values, kind of some information about this variable, about this model, sorry, t values and stuff. This is kind of the thing that's, if you're interested in this stuff, it's like super interesting, and if you're not, it's like the worst thing in the world, and it makes absolutely zero sense. So we won't dive too deep into this, but yeah, as Andrew said, I think it's cool just to kind of see how you would actually fit a linear model. Yeah, and if you wanted to, no, yeah, it's all right. And if you kind of wanted to, the Broom package is really good for kind of looking at these outputs and kind of controlling the outputs of these models. Okay, so that's, yeah, as I said, a really shallow dive. Programming is the kind of final part that we haven't touched on, which is just outside here. We're not going to, again, we're not going to go too in depth into this, but there's a package called per, and what this allows you to do is to kind of work more efficiently. If you're particularly interested in kind of the performance and the speed of your functions when working with sort of tidyverse functions, then the per package is what you want to be using. And what this allows you to do is, you might have seen functions such as lapply or vapply, and it allows you to kind of iterate over multiple kind of sets or subsets of data all in one go, and it does this really efficiently. And so it does this via these map functions, which I think we're going to show really quick. And I think it's probably the easiest way to kind of show you this. So let's jump into our studio. This is what we're going to be doing. So let's program. We're going to be using this per package with 3 R's. The first thing I'm going to do here is, will be slightly confusing, but we're going to use a function called nest. This is from the TidyR package that we saw earlier. But what this function does is, if I run this code and look at the sport data, it kind of creates a table within a table, if you like. And so what it's done is it's kind of grouped by these individual sports, and it's created an individual table, an individual tibble for each of these sports, where if we were to then look at the data of this sport data, we can see that hey presto, we've got kind of an individual table of all just for these individual sports. So this is relating to, I'm not sure what this is, this must be whatever the 27th sport was. This will just be a table of just those values, and similarly we've got a 26th one going all the way up. You can see quite a massive long list of these little tibbles. And now we've got this, we can use some map functions to kind of iterate over this new list that we've just created. So let's have a go at trying to do that. So let's create a sports model, and let's use this map function that we kind of very briefly touched on. And what we're going to do is we're going to provide the sports data that we've just created, this list of all these little data frames, and we're going to fit a linear model onto each of these little tibbles. So we're going to do this. We need to specify again this little twiddle here, this little tilde, and we're going to be fitting a linear model. So yeah, thanks Andrew. That would have been good if we hadn't gone over that. So we're going to fit a linear model. And we're going to do in much a similar way. We're going to fit the funding and the year. So we're going to try and predict the funding by the year variable. And our data is going to be, we're going to use this full stop here to just kind of signify that our data is this sports data. When we run a code like this, we can see that it's very quickly executed. We've already got this execution as completed. And if we were to kind of look at this model, we can see that here we have we've now converted our kind of 27 little tables into 27 fit linear models, all kind of relating to their individual data. So this is kind of a really efficient way of doing this. And if we wanted to, we could even perform some kind of follow-up analysis on this using the Broom package. I'm going to copy and paste this in here just to kind of, in the interest of time. But what we're going to do here is use this per package again. We're going to take our data, we're going to take our models, and then we're going to use this add residuals function from the Broom package. And this is going to allow us to kind of look at all of these models that we fit and see the kind of the residuals for each of these. And then we've specified an ID column here. And this just means that we're going to kind of add these residuals to our original data frame. And so I think the easiest way to do this is to run this code. And I've misspelled something somewhere. Sport data, sports models.
No S on the end, just sport model.
Yes, there we go. Cheers, Andrew. There we go. Cool. And when I've run this, now we get back our original data frame, but this time we have some residual values appended onto the end of it, if you like. So this, I mean, this is only one use of when you might use this per package, but if you ever are looking to kind of iterate over many observations, particularly if you ever find yourself using this kind of a for loop, which you might have seen before, then the per package is a much better alternative to using a for loop. Okay, cool. We would have another exercise here, but as I said, we're kind of getting on in time. So let's kind of go on to the final sort of chapter. Andrew, I didn't know if you had wanted to say too much about this. You can kind of keep it on my screen.
Yeah, no, not really. I mean, so we kind of mentioned at the start that there's not really many packages within the Tidyverse that are used for communicating. It's really just sort of the first 5 things that you see. But it is kind of worth just mentioning what you can do in R with your results, just very briefly.
Yeah, definitely.
Yeah, so a few examples of packages. Shiny, I don't know if any of you have come across this, maybe not, but Shiny basically is where you can create apps that work from within R. So you create an sort of application interface where the front end looks really, really nice to the user, and in the background you're using loads of R code to sort of run it and show whatever you want. Shiny's really nice, integrates well with like stuff like RStudio Connect. But yeah, Shiny's really good. Have a play around with Shiny if you want to show your results in a nicer way, because it does look really cool and it's quite fun to sort of play around with the dashboards. R Markdown is just, so there we were entering our code into an R script. R Markdown is almost like, it's almost like a document when you can just write text and write words, and then you can put in little code chunks, which are almost like little mini scripts where you just have a little bit of R code. So R Markdown's good for sort of combining like, say your visualized plotted output with some maybe text underneath it where you say, oh, and our conclusion from this plot is that. So that's R Markdown's good for that. And that's available just from inside RStudio, new file, R Markdown file. Flex dashboard I've not really used, but I think that's similar to Shiny. Have you used that at all, Joe?
Yeah, I've used it a few times. Yeah, it allows you to kind of just produce some more kind of rudimentary dashboards as opposed to Shiny. It's kind of just more, it's slightly easier to set up, and you can kind of just send a Flex dashboard file if you like, rather than having to host Shiny on a server. But yeah, it just allows you for some kind of basic dashboards that kind of allow you to interact with your data a little bit, which is kind of nice. But yeah, nothing more to say about that. Cool. Okay, so that kind of brings us to the summary of what we've been looking at. Let me just jump on to the right thing. Cool. So yeah, living in the Tidyverse, hopefully we've managed to convince you that the Tidyverse is this really powerful tool that kind of allows you to perform lots and lots of different operations to your data, and it kind of provides you all of the fundamental steps as a data scientist to kind of perform an analysis, visualize it, model it, and then kind of communicate it. And yeah, it provides packages for all of these stages. There are a few more resources that are available. Obviously, this is not the the be all and end all of the Tidyverse. We would really recommend you go to this RStudio cheat sheets. There's absolutely loads of these cheat sheets, which basically, if you're ever kind of getting started with using a package, I'd really recommend going and downloading the cheat sheet for that package, because it's just a kind of really useful, quick thing to kind of look at, say, oh, I've come across this error, what's going wrong? You can just look at this cheat sheet, and almost certainly a reference to that function you're using will be in there, and you might be able to see where you're going wrong. But also there's this book called After Data Science, which is kind of publicly available at this link here. And this is kind of your kind of go-to, your kind of almost gospel, if you like, as a data scientist. This is your kind of your bread and butter for what you want to be using in day to day. And this book actually has its own exercise in it. I'd really recommend it. I find it personally interesting. There were certain things I hadn't considered when working with the Tidyverse, and it's got some really interesting stuff. I don't know if you've used that, Andrew, if you've ever had a read through that.
No, but it's definitely been, people have recommended it to me before, but no,
yeah.
myself, but yeah, I mean,
yeah, fair.
Very well known.
Yeah, absolutely. And Hadley Wickham's the big name, as it were, in the R world.
Yeah, he's the guy that wrote a lot of these packages that we talked to you today about. So yeah, he knows what he's talking about.
Yeah, yeah, absolutely. Okay, I think that kind of brings us to the end of this this webinar. Hopefully you have all found this useful. Thank you for coming. I don't know if Andrew or Laura, if you have any kind of closing remarks about
yeah, sure. Thank you, Joe and Andrew, for that. That was brilliant. Just to say that I will email out the slides and a recording of this session tomorrow, so keep an eye out for that. And yeah, thank you very much for attending, everybody.
That's great. Yeah, cheers, Laura. Thanks all for coming.
Bye, everyone.
Thank you, everybody. I hope you enjoyed it.